Hi, my name is Nurfatia binti Zulkifli with ID number 17004851 and I am from Chemical Engineering Department.
Hi everyone, my name is Wong Sen Wan. My ID number is 16003946. I am from CE department.
Hello, my name is Daniel Haris bin Ahmad Nizam, metric number 17004263, and I am from Mechanical Engineering Department.
I'm Tan Litong, ID 17002803 from Electrical and Electronics Engineering Department.
Hi, my name is Nazrul Aiman bin Mat Ahir. My ID is 17005555 and I'm from Mechanical Engineering Department.
Introduction. Drunk driving issues has become a hot topic in Malaysia once again. From the Transport Ministry data, around 2,364 individuals were affected by the drunk driving cases in Malaysia from 2010 to 2018, with about half of them are dying and about half of them either suffering major or minor injuries. Problem statements. The problem statements are: first, rate of road accident due to drunk driving is worrying. Second, ineffective law. There are two ways to detect drunk driver, but the current practice to detect drunk drivers is ineffective and unreliable, which are detect BAC using breathalyzer, and secondly is to observe abnormal driving conditions. Objective. The objective of this study is to first develop an easy install prototype that can measure the alcohol concentration in the air inside the vehicle. Second, to utilize the artificial intelligence, which is using face recognition technology in drunk detection mechanism.
It's my turn to talk about literature review. According to drunk driving penalties in Malaysia, drunk driving is one of the contributors of road trauma in Malaysia. If a person is caught by drunk driving, the person would face serious penalties. In Malaysia, the legal blood alcohol concentration (BAC) limits for a driver is below 0.08. The problem of breathalyzer include error margin, partition ratios, radio frequency interference, improper calibration of device, leftover alcohol in the driver's mouth, tainted breath, and even affected by the psychological factors of the driver such as gender and body temperature. Now is design thinking. First is analogous inspiration. Having the problem of breathalyzer in mind, our team started to brainstorm ideas. Instead, we noticed a sensor called Non-Dispersive Infrared sensor NDIR and also artificial intelligence, specifically facial recognition. Second is survey. Our team has conducted a survey to get more insight on the project. The result shows that 98.9% of the respondents know what is drunk driving. There are also 35.9% of the respondents personally encountered a drunk driver before. The result shows that 91.3% of the respondents agree that a drunk detection system can reduce the rate of accidents. Among them all, 62% of the respondents look for affordable pricing, 63% of them looking for easily installation, and 70.7% of them looking for safety features on the drunk detection device.
Hello, my name is Daniel, and for my part of the presentation, I will be talking about our project planning, methodology, and the design concept. For our project planning, we are taking 6 major steps, which are identifying the problems, brainstorming ideas, gathering as much ideas as possible, simulating the ideas, testing the simulation, and improving the simulation wherever possible. As you can see in the Gantt chart, we spent the first 4 weeks of the semester brainstorming ideas, deciding on the best idea, and working on our first submission, which is the extended proposal draft. Following week 4, our team began to slowly develop our project prototype on AutoCAD and also started working on our simulation, video presentation, and design concept presentation. Moving on to the methodology, you can see that there is a flowchart of how our product works. It starts with the driver entering a car, and the NDIR sensor will sense the breath of the driver and detect the face of the driver. The two sensors will determine whether the driver is sober enough to drive or the driver is drunk. If the output is normal, the device will allow engine ignition for the car to start. But our product flow doesn't end here. The device will take an image of the driver every 5 seconds to ensure the driver is not drunk after the car has started. If the driver appears to be drunk, the buzzer will start to beep and an LED light will start to blink, indicating that the car needs to be stopped within 5 minutes. Next is the design concept. This is the design concept of the product. As you can see, there is a camera lens at the top of the device which is used for image recognition. At the bottom picture, you can see that there is an infrared light which is used to detect breath the breath of the driver and the infrared detector will detect any changes in the infrared light to determine if the driver is drunk or sober. There is an LED light at the front of the device and also 5 holes which are slots for the surrounding air to enter and exit.
Based on the previous section, we have known that this project is divided into two parts, where the first part is a face recognition system that can predict whether a driver is drunk or normal. The second part is an NDIR sensor that can give the BAC reading of the driver. We have 4 scenarios here, where the first scenario is when a driver is classified as normal and the BAC value is less than 0.08. This driver is definitely good to go. The second scenario is when a driver is classified as normal but the BAC level is greater than 0.08, so this driver should not drive. The third scenario is when a driver is classified as drunk but the BAC value is less than 0.08, so this driver still can drive but needs to be extremely careful. And the last scenario is when a driver is classified as drunk and the NDIR sensor value gives a BAC of more than 0.08, so this driver should not drive. And if you wonder the accuracy of our face recognition system, it is 98% accurate based on 600 test dataset.
In conclusion, as the drunk driving issue arises these days, we as engineering students came out with this idea as the possible solution from the technology's perspective. The idea are to prevent drunk people from driving and can also alert them if they are already driving by implementing NDIR sensor with the face recognition features. Therefore, our aim is the accident cases related to drunk driver could be possibly reduced by this idea. Next, we will look at our recommendation that could be done to improve this project. First thing is by using a better camera. We use a good quality camera with high definition and high resolution so the camera can read a better image. And the second thing is related to machine learning. We can increase our data set so we can get more samples, give a learning algorithm more opportunity to understand and make the machine learning be more precise and accurate. So for the third recommendation, we could make the design be more flexible so it can fit to any kind of surface on the different steering wheels. Next, the fourth recommendation is the idea is to make the NDIR sensor can control the car speed, which is slowing down when it detects the drunk driver and eventually stopping the car. Lastly, the NDIR sensor able to turn on the hazard light automatically so it can alert the other driver when the car is slowing down.